So what I'm going to talk about today is archiving engineering documents using PDF. And I'm going to talk pretty much just about 3D because we talked a little bit about 2D in the last, in the PDF Tron session. But I'm happy to answer any questions that anybody may have about 2D as well. Because it's CAD, which is itself an acronym, we love acronyms. So we have a whole bunch of terms and definitions. So we're going to talk a little bit about that. Then we're going to talk about how PDF gets used in engineering. And then we're going to talk about how you can archive these things called technical data packages. And I'll define those right away. So my terms and definitions are a 3D engineering perspective. I'm not an archivist or anything. These are the way that we think about data at the consortium. So I want to talk a little bit about what makes PDF different and why it's a different format for engineering. And I do that typically by talking about the kind of information that you move in engineering. And the first thing we talk about is data. You know, everybody loves data, and it's the world of the big data anymore. So we look at data as just being some sort of numerical data that you can do something with. All right, it's just an unstructured big bunch of data that's out there. And when you put that data and you put presentation around it, you get a document, okay? And right here I'm showing a 2D document because I think that's a 2D drawing. I think that's a great example of a document, right? It's data with presentation level and you get a document out of that. When I think about a record, you take those same things that we had there, data and documents, and then you add security to that. What I mean by that is a record can have you can have all kinds of things. It has to be persistent. It has to have some sort of, we talked about digital signatures earlier, it typically has a digital signature or something associated with it. So a record is a persistent thing with some level of security. And then the final thing that we have is we have archives, and that's when you put them all together into a big package, right? And it goes over time. Each one of these, the fun thing that's different about each one of these adds something to the previous one, right? So like if you're thinking about a record, I may need a record for a short period of time, but I'm not so interested in archiving it. But if I'm making a wing for a 787, I want it to be around for a long time because I'm going to have to possibly do something with that information later on. So each one of these builds on each other. And the thing that's interesting about PDF is really the only format that we think addresses all these things. You can use HTML for a bunch of these things. You can use other proprietary formats, but the only one that works in a whole open environment is the PDF standard and the PDF document. Let's talk a little bit about some more of our terms. This is a drawing. We've seen a bunch of those earlier. It's basically a 2D representation of something that you're going to manufacture, okay? And the thing that's interesting about a drawing is drawings aren't digitally, you can't really use a machine to read a drawing. Inside of a drawing, there's a whole bunch of different things, dimensions, tolerances, other types of things that have symbols that you have to interpret, and they're more meant for human consumption than they are for machine consumption. A model is a 3D, you add another axis to that drawing, right? So now you're not in a flat world anymore, you're in the 3D world, and you have a model. And the thing about the model is that it is now, because it gives you the full description, it is now machine readable generally in addition to being human readable. So we both have a machine readable and a human readable part. And that's what's great about 3D is it allows us to manufacture without having half a person interpret it, okay, in the whole process. And that gives you a whole scale of cost savings. Next thing we'll talk about is PMIs, product and manufacturing information. That's geometry, that's dimensions and tolerances and other things that you need that's going to describe how you're going to actually manufacture this part, right? So model gives you shape, but if I want to know how it fits together, form, fit, and function, I typically need some level of dimensions or tolerances that are going to tell me that. And the final thing is when we wrap all this up, we would get what we call a technical data package. That's when we put all the information that we need to manufacture something into a single package. We like to think about it as a PDF file because you can put all this information in a PDF file, but it gives you a bundle that I can give to somebody else, and they can take this technical data package and they can manufacture exactly what it is that I need, okay? Because it's all contained and it's non-ambiguous. It has all the information that I need. As I said, PDF we think is the only open format that's capable of doing all these things that I just talked about. It has PMI in it, you can make TDPs out of it, you can put 2D drawings into it, you can put 3D models into it, you can do records, archives, you can do all these things in a PDF file. There is no other format that allows you to do that. And on top of that, you can visualize it, you can view it, you can measure it, you can mark up, you can do all these things. That is the value proposition of PDF right there. It allows you to do things in a simple and move complex information in a very simple and easy to use manner. Now, 3D PDF has been around for a long time. If we go back here, I think that in 2004 was the first version of Adobe software that added 3D to it. So now we're coming on the 14th year of 3D and PDF. So it's a stable and mature technology that's been out and widely used. In addition to that, over the years, more and more CAD software has been putting out PDF in their software. So you have virtually all of the CAD manufacturers can do a 2D drawing, and they're starting to move to this 3D model as well. Autodesk Inventor, as we mentioned earlier, was one that puts out 3D natively. Solid Edge, PTC puts out 3D PDFs, and SolidWorks does as well. Now they put different information into their PDFs. So like if I bought a PTC, if I bought Creo, and I wanted to output a 3D PDF, I probably wouldn't get the interesting information. I wouldn't get the dimensions and the tolerances and things like that to come out of that in the PDF model. But if I used Solid Edge, I get all that information in my file, right? So each one can create a PDF, but not all 3D PDFs are created equal. In addition to having these 4 CAD packages that put out PDF natively, we also have a number of CAD plugins. So virtually from any CAD software, you can get to a 3D PDF. Now, what makes a 3D PDF? Well, inside of a PDF, you have all these great things. This is ISO 32000, right? That's your standard definition of a PDF file. For a 3D PDF, it's just a PDF with 3D in it, right? So it's the exact same file, but we add 3D artwork. Typically, that's a model. We may add some 3D JavaScript for manipulating that model and doing some custom programming of that model. And then we can do some 3D markup on top of that. We can measure it, we can put comments, we can do any kind of markup. And PDF has subsystems for all these things built into it. So when people talk about 3D PDF, it really is just a PDF. But it's an ISO 32000 file. But we add 3D to it so that you know that inside of it's a model and is typically used for some sort of an engineering practice. Now what we think is for viewing, there's a number of different viewers out there for PDF, but there are not a lot of viewers out there that have embraced 3D. The one that has the most is the Adobe products, right? They started the PDF, 3D PDF. They are definitely the premier solution for it today. They do some things that they're the only ones who do it. So inside of PDF, this 3D data, you can carry it in 2 types of formats. One's called U3D and one's called PRC. If there are other 3D viewers, most 3D viewers will only view one of those, 0 or 1. And the Adobe product will view both of them. So if you're getting a 3D PDF and you want to be sure that you can read it, we find that the Adobe product is the one that certainly has the best track record of that. So let's take a quick look at a business case for 3D PDF as well. One of the big users is General Electric, and I think it was last year, it was 2016 or 2017 in their annual report, they put in a few slides about what's happening at their power, process and power, I think is what they call it at GE Power. And they have made the commitment to 3D PDF for their whole organization and putting all their information in 3D PDF so they can move it around really quickly. One of the things that you'll see here is that they had an enormous amount of cost savings. Now, what this is what we call model-based definition. I should have put that on my terms of definitions. But what that basically is it's drawingless manufacturing. So I said everything that we've always built off of drawings. And that gave us such great things as the Ford Pinto and the Chrysler K car and all those really fine automobiles from the 70s that aren't on the road anymore because they don't really work. That's a 2D drawing. And then we moved into 3D, and we got these new products, and now we have Mercedes and Porsches and all the fine cars that we have today that last forever, okay? So MBD is moving from this 2D way of manufacturing, which has to have people involved and is error prone, into a fully digital way of doing it with a 3D model. And you don't have people involved and you get higher quality products. They did this at GE too. And one of the things that they find is that when you have a CAD model and you need to make a engineering change on it, which is frequent that you need to do this, if you have a drawing-based environment, you have to remake your drawings because you start with a 3D model and you have to create a 2D drawing with all the dimensions in it and then send that off to somebody to manufacture. Creating that 2D model for something complex, 2D drawing for something complex like a nuclear power plant can take a tremendous amount of time. But if you use a 3D model and you do all your dimensions in 3D, it's all right there. And so an engineering change is a lot simpler to make because your dimensions all change automatically with it. I don't have to have somebody else go out and create 2D views and other things of it. So they found that they had significant results from this. And you'll see here they $103 million across 3 years. That's significant for any company, right? And that's the process for moving from 2D to 3D for your manufacturing. And we feel that if you're moving from 2D to 3D, and everybody is, because it's not a flat world anymore, when you move from 2D to 3D, the best way to move your data around or information is in a 3D PDF file. So when you want to archive these 3D PDFs or want to archive some engineering data, you have to go through a bunch of questions because there's not really a great format for it today. There's not a fantastic solution for archiving of a 3D PDF. And the reason for that is that the standards have not really always embraced 3D, or they've embraced part of that 3D. So in the 32000 standard, the original 32000 standard, it specified that there's only one type of 3D you can put in, and that's a U3D file. And then we added this new, better format called PRC, and that didn't get put into the standard until in PDF 2.0. In addition, if you look at the PDF-A standards, PDF-A 1, 2, and 3 don't allow you to have 3D. You can put a 3D attachment, so I can put a model on a PDF-A3 file. Only PDF-A3. PDF-A and PDF-A1. If you have some drawings in a PDF file, you could probably archive those using one of those two formats. If you want to add 3D to that, you'd have to use PDF-A3, but you couldn't view the PDF inside the PDF-A3 file, right? You'd have to attach it. Well, we looked at that and we thought that doesn't really make a lot of sense. How can we allow you to put something that wasn't authored in PDF as an attachment to a PDF file, but we won't let you view something that's in a PDF file because it's an archive? So what we've done in the next version of PDF-A is we have suggested that we add a conformance class so we can have 3D in there as well. The idea is that we have a single standard for archiving that will embrace both 2D, 3D drawings, everything you would need in the engineering world. Right now, that's simply in a draft, and we hope that that will continue as we move forward, but that's where we stand today. There really is no good archiving format itself. We suggest that if you need to archive today, use the PDF 32000 specification. We prefer to use 32002 because it allows you to add PRC to that. And then after that, then you have to use some recommended practices to make it all a single file so that it's really good for archiving in the future. We expect that the PDF A4 format will codify all this, so we'll have a single format, and we'll have one for archiving of PDF 3D information. But today, you have to use the 32000 for your archiving, and the PDF A stream doesn't work. So hopefully I've confused everybody, because it's a difficult thing to think about. Now, if you are going to make a technical data packaging and put it all together and you want to archive it, we suggest that you use attachments or portfolios or something else to structure your information. Because once you get information in a PDF file or any kind of a container, the most important thing is how does it all relate to each other, right? If I give you a zip file worth of data, I give you a zip file to make any kind of this table here, right? It have a whole bunch of instructions in it, some drawings in it, maybe a 3D model and a whole bunch of other things. And you'd have to go out and figure out how they all interrelate together and which portions of it you would need to do your manufacturing. If you use attachments and portfolios to logically structure your data, to put metadata on, other types of things, when I give you a PDF file that has all these attachments in it, now you know certain things about it. If it's a PDF2, you can tell what the source file is. You can tell a number of different things about it. It allows you to, you can put notes on it, descriptions, you can do a number of different things with it. But what we think it does is it allows you to put structure so that when you hand it to somebody, they can more easily understand and digest that information. The other thing that we talk about when we archive them is this 3D data that's inside of it, right? So a PDF file can be it's a number of different files. In terms of the 3D PDF file, you got the 3D data, and that's stored in either U3D or PRC, and then that's wrapped in a PDF file, right? And so you have a number of different standards that you have to think about when you do these things. We recommend that you use PRC as the 3D data inside of it. And that's because the really cool thing about PRC is it's an engineering specific format. So it has data structures for PMI, for all these other, for views, for everything that you would need in a full 3D model. It's all built into this PRC. If you use the other format, U3D, it doesn't have all these native structures. So it's not going to have the rich data set that you get out of a PRC file. And then we always recommend that you add a file to that. So the thing about PRC, again, is it's full digital definition. You can put all your geometry into it. You could manufacture off a PRC file if you found software that read a PRC file. There aren't many of them out there. The number one file format, open file format for manufacturing is a step file format. So what we suggest that you do is you put a step file, attach a step file to a PDF file, use the PDF file for all your viewing, all your collaboration, measurement, markup, or whatnot. But if you need to actually cut a part, you then go ahead and use that step file to cut that part, because every CAD system reads a step file, so it becomes very easy. Now you have a lightweight visualization software for containing all your information and collaborating and visualizing, and then when you need to cut the part, you have the actual digital representation. Then we also recommend that you make it portable. And portability is kind of, it's the first P in PDF, right? And that means a few things. It means that has to be a self-contained document. So we recommend that you put a poster image in for all your 3D. You don't have to do that. It's a recommended thing, but we recommend you put a poster image in so people can see that without having to activate it. You can use watermarks. We suggest that you embed fonts so that when you send it to somebody, they don't require a font. It's all in the PDF file. If you do these things, you'll make it a completely portable and self-contained document that you can then go ahead and deliver to somebody else. The one that I'd like to really emphasize is fonts, because fonts are very important. In the CAD world, we use a lot of different fonts, and where we use them around mostly is these dimensions and tolerances, right? Because they're your standard Times Roman, oddly enough, does not have a perpendicular tolerance symbol in it, right? But there are some ones that do, and in Adobe they come out with this one called Myriad CAD, and it ships with all the Adobe products. They have their own font. But if I'm using AutoCAD or Inventor or CATIA, and I go in and I put all my dimensions on it, I use a CATIA or AutoCAD specific font with that. So then I give it to somebody else and they use my font, it looks different. It has the exact same information in it, but it looks different. And then I give that to a QA guy or a quality guy, right? Now that guy who I give it to is the most picky person on the face of the earth, right? Their whole job is to find problems. You give me a part, I'm going to find every problem in that part. You give me a file, a visualization file, I'm going to find every problem in that visualization file. And the first place they go to is those fonts. This looks different than my CATIA model. Well, it's the same information. Yeah, but I think it's 0.01 millimeters different in this model than it is in this model. It's like, is that a problem? I'm not sure, but it might be because it's different. So every time I go and I talk to somebody, I always say, try to get your fonts in there first and foremost, because then now it's going to get to your quality department because it looks exactly the same way as it was when you published it, okay? So I think that that's always an important thing. Next thing is use JavaScript, and we're probably the only people here who's going to tell you that today. Use JavaScript and use a lot of it. The reason for that is because when these models themselves, JavaScript is super powerful. It allows you to make up for certain things that maybe your viewer doesn't do well. So in the case of 3D, when you click on a dimension, you typically want to know what it is it's dimensioning, right? Let's say I have two faces on a block, and I have a dimension between the two of them. When I click the dimension, I would like both those faces to highlight so I can see it really clearly and is non-ambiguous. The Adobe Reader doesn't do that. It doesn't highlight geometry. But you can put JavaScript in your file so that when you click on that dimension, it highlights both those two faces. And that's what the majority of our software vendors do, is they use JavaScript for that. So we recommend you use JavaScript to get the kind of behaviors you need for whatever your workflow is. It does mean some really great things when you do that. It means that when I give you the model, it behaves exactly for you the same way it did for me. And we like that, right? And so your behavior moves with your model itself. Now, in the archival world, JavaScript's a four-letter word. And because it's interactive, right? And it's unpredictable. And in archival, you want predictability. But in 3D, you need that JavaScript in order to make sure your behaviors are exactly the same. So it's a difficult thing for archivists, I think, to talk about sometimes or to understand. In 3D, you have behaviors that are actually part of your model. You can control what, if I click on something, something else gets highlighted. The JavaScript is what I need to do that. So to archive 3D documents, we always need JavaScript to do that, because the behavior of the 3D is controlled by that JavaScript, and behavior needs to be archived as well, the behavior of the model. A quick story about that is that at Boeing, actually, the 787, all their assembly instructions are in 3D PDF. And so when they go out on the shop floor, they look and they see how they put the 787 together. It's a 3D PDF they look at. There was a problem with one of the with a tail section. They had somebody who was out there working on it, and the first thing you got to do is you got to drill some holes in these tail sections, right? Well, that's great, but this is a carbon fiber tail section, right? And so when you begin to drill in it, it's a little bit more difficult to fix one of those than it is a standard metal piece. So they went out and they drilled a whole bunch of holes into this thing, and they were all wrong, right? And the reason that they determined that they were wrong was because there was no visual feedback. Lots of time you'll have a dimension and it'll point to a whole bunch of different things, right? If you're drilling holes, you'll typically have a dimension that tells you how big that hole is, and then it'll point to all these different dimensions on all these different holes, and you know that you have to do them all exactly the same, right? They had to throw away that tail section because to repair it was going to be going to cause a lot of problems for them. That was a super expensive problem because they did their PMI, their dimensions didn't cause their geometry to highlight. Okay? Now, if I remove that JavaScript so your dimensions no longer highlight your geometry, I have a completely different 3D model than what I had before. That's why JavaScript's important. That's why it's important for archiving of 3D. And that's why we're high proponents for that. Big proponents. All right, so that does it for me. That's my spiel today. If you have any questions, I guess we have some time.
We have
now.
time for questions.
Excellent.
If I understand correctly, if I want a self-sustained file, 3D PDF file, I need 3D PDF file and step files attached to it. So with this container and the step file, it's going to be dropped to computers with a little bit and all of it like this. I understand correctly?
You understood correctly, yeah. If you want to manufacture it, and if you want to cut apart, we recommend you put a step file in it.
Are the tools right now is that we export to PDF from CAD Software? Can they automatically create those step files and attach it to PDF, or this is a manual process right now?
So the question was, if you create, if you use a CAD system to create a 3D PDF, can you automatically add step file, create a step file, and add it to? The answer is generally yes. Yeah. So step is, I don't know a CAD system that doesn't read or write step, right? And all the CAM systems, and virtually anything in manufacturing uses step. So yeah, and most of the solutions, when you create a PDF file, you can simply tick off a box to add a step file to it. There are some that do not allow that, but then you can attach it using, using your viewer.
Just one thing on that, I would caution, we've seen that step files with PMI, sometimes it doesn't create them correctly from our CAD system, so you just have to inspect them. It turns it from inspecting a drawing to inspecting the 3D PDF.
Oh, okay. What system do you use?
NX.
Use NX? Okay. I know they work, so I know the Siemens guys participate in all the step stuff, so they're really a high proponent of that.
Can you use the JavaScript to connect parts of the document into the 3D model?
Glad you asked that question.
What was the question, Phil?
I don't have one on this machine because it's not my machine. I typically have that. So the question was, can you connect parts of the, what I call the flat PDF, to the 3D PDF? So if I have in the page in my document, perhaps on the same page as my 3D scene, let's say I have a table, and that table has a bill of materials, and can I click on something in the bill of materials and have it do something to that 3D model? Is that right? Yeah, absolutely, you can do that. The JavaScript allows you to interact, have the flat parts of the PDF interact very well with the 3D parts of the PDF. It's all very possible with that. But I'd be happy if anybody would like to see one of those. I have some examples I'd be happy to show you. Or we have under Gallery on the 3D PDF Consortium website, Showcase, sorry, you can find a bunch of things you can download.
Do you know if there is any work on trying to create a more sustainable, archival version of the PDF 3D?
Yes.
Question.
Question is there a work to do a more sustainable or archivable version of 3D PDF? Yes, the PDF A4 work is a good one, and in the PDF A4 work, we added a conformance class for 3D that would allow you to have JavaScript and other things in that. So what we've done in PDF A4 is we say, here's the PDF A that you've all known and loved forever that applies to flat PDF. Use that. But if you want to use 3D, we have a conformance class that adds some more things to that so that you can now do a conformance class for 3D. The other thing that we're looking at right now is STEP is an ISO standard. It's ISO 184, TC 184, excuse me, ISO 10303. And they are working with us right now on a joint project to see if we could put STEP as a 3D stream into PDF. So right now you have to attach a step file. So you have a PRC file that shows used for visualization or viewing. You have a step file. What we're looking to do is, can we remove the PRC file so you just have a step file, and then that's the only 3D definition inside your model, inside your PDF file. So you view directly off that. We're right at the very beginning of that process, so we'll see how that goes, but we're definitely looking at that. Any other questions?
You briefly mentioned PDF 2.0. That's going to be mostly focused on geography, geospatial stuff, right? Not necessarily engineering?
Right. So the PDF 2.0, from the 3D parts, the parts that get me excited, right, is it added PRC. So it will definitely be an engineering, mechanical format, because PDF 1, the way the PDF went is the standards kind of were a little bit behind the Adobe implementations. So PDF 1, there is a annex to PDF 1 that Adobe wrote that allows PRC to be in a PDF 1.0 file. And so we codified all that in PDF 2.0 so you can do PRC or U3D. So we think that 2.0 is going to be a very effective engineering format for the future because it actually codifies and puts PRC in there as a first class 3D stream inside of a PDF file.
And geospatial data is also defined? I think that was the question, right?
My bad, yeah. And the way that it all works, right, is that there's a single 3D representation inside of a PDF file. It can be a geospatial or it can be a mechanical. It can be any of those things. If it's geospatial, there's some extra information that gets added to the PDF file, but underlying it is all the exact same representation. So the way I look at it is if it's good for geospatial, it's good for mechanical, right? The underlying 3D portion of it is all shared, and then we have some specific geospatial and some specific mechanical stuff. Any more questions? All right, thank you, everybody.
Thank you.